can get started. I've never had this many microphones in my whole life, but it's good. Okay, so we can keep whatever I'm gonna say today. So thank you again for joining. Today, what I'd like to do is to talk about a certain technology which appears in a very nice TV series called Silicon Valley from HBO, in which a very smart guy decides at a certain point to create an application to detect whether something appearing in an image is a hot dog or not. So this is the Hot Dog, Not Hotdog app. But the same technology is used also to capture text that a camera can see and translate it in multiple different languages. And at the same time, it is used to detect potential fraudulent transactions while we do online shopping. This technology is machine learning, and today I would like to give you a little bit of the basics behind it and make you familiar with some ideas about how you could use it in an application and in the real life. So my name is Umberto Mattei, and I work as a customer engineer at Google Cloud. Basically, what I do is sit together with the developers and help them figure out which kind of Google Cloud services they can use to build their apps and how they can optimize them. The talk itself is meant for beginners, so there's going to be a little bit of the basics of machine learning, and it's going to be more like heavily product-oriented because that's what I do in my daily job. So I'm going to be talking about the services we have in cloud, but that doesn't mean that you cannot ask questions about anything else. So whatever you want to shout, just please do it. The talk is going to be in English, as it was mentioned just before, but you're free to stop me at any time and ask questions, both in English or Italian, or tell me if you don't understand something. I'll just translate it back. Okay, so let's get started. The idea about the agenda is talk a little bit about the basics behind machine learning and the products that we have in Google Cloud. And then I would like to jump more into the, I think this is more of a nice idea, the roles that a person could have, like job roles, when they work with machine learning. And here we have, of course, the app developers in general, but we also have other roles that are more tied to this specific discipline. One would be the one about the data analyst. This is a person who generally is able to analyze different types of data to make informed business decisions. But then we also have those tough engineers and data scientists who are the people who are basically experts in maths and statistics, or are software developers capable of maintaining those services that we typically use for doing machine learning. And then in the end, I would like to make it more mobile developer oriented and mention a little bit of some of the integrations we have to make doing machine learning very easy when we're developing an app for mobile. So machine learning itself is considered as a branch of artificial intelligence, although those terms are used interchangeably. Also because they sound pretty cool, so everyone is sort of throwing the buzzword in every now and then. And the definition is that this is a way of doing so that a machine can solve a problem without having the solution explicitly coded. So what we do is we try to build a system which is capable of learning how to solve the problem. In this talk, I'll be focusing on a type of machine learning which we call supervised machine learning. And in this case, what we do, we usually gather data about the problem, and we associate the solution to that problem. And then you're going to be wondering, why do I want to solve a problem if I already want a solution? Well, we do it because then we build a system which is capable of learning from those problems which were already solved, and they will be able to solve a new problem of the same type. So we talk about such a system with the word model, and we use training as the act of learning on those data points that we have. And we talk about those data points as data set. Then in the end, once the model is ready to be deployed, we talk about inference as the act of feeding some new data into it and getting the result based on the training that the model has done previously. Just to give you a more practical example, here we have, for instance, a picture, and we want to understand that if within the picture a cat or a dog appears. What we do is we put together a model. In this case, the model we're talking about is a deep neural network. And this is don't get scared by the word, it's just a model which is supposed to be built in a way that mimics how people think. And by feeding this image through the model, we will be able to detect if a cat or a dog appear. And here's a dog. One big effort from Google's standpoint when it comes to machine learning is working on TensorFlow, which is an open source machine learning library which lets you define models, but also train them and serve predictions. There are a couple of nice reasons for using that. The first one is that it's very flexible, so it can be used for many different types of use cases. But at the same time, it's very portable. So basically, the work that we do there can be ported across different types of infrastructure, and even actually arriving to the point that we're able to run machine learning on a low-end mobile device itself. And then, of course, it's open source, which is one of the great aspects of the philosophy that many Google products have, because we don't want to be stranded in a technology island and be the only one using a certain technology. So it's great to have this exchange with the whole community when it comes to making products better. From the ecosystem standpoint, again, now that's where we go more into the different roles that a person can have when approaching machine learning. And here we have a whole spectrum where we go from this side. Yes, it's not flipped. From this side, thanks. Where we have more like simple ways of using machine learning. And here, what we have is something that at the same time is a bit less customizable. We're talking about machine learning APIs. Here, we don't even really care about how this do the job. It's just pre-trained models that Google take care of, and you can just use them to feed some data and get the solution to a problem. At the other end of the spectrum, over here, we actually have stuff that is way more customizable, but way more complex to manage. And we talk about typically handling TensorFlow implementations directly. And here we have some suites of products for collaborating on advanced machine learning projects. And we also have things like Kubeflow, which is the way of making it easy to implement TensorFlow on Kubernetes. And we usually like to use it when we want to have very high portability across different environments. But then there is a very interesting product which sits in between, which is typically called AutoML. And here we usually use this product when the pre-trained models are not able to solve the problem I want to solve. Over here I want some degree of customization, but I don't want to necessarily get into the weeds of machine learning and manage a super complex model and training process. And then I also sprinkled around a little bit the mobile developer part, because we have some products which let us have a layer, an API layer for accessing services, both in the machine learning API and the hybrid space with AutoML. As we just said, machine learning APIs, we have a model which is already pre-trained and taken care after by Google itself, and we just feed something through it, like for instance an image, and the API will be able to tell us, for instance, object detection API, if there is some specific object, prominent object appearing in that image. Another way that is very interesting to use this is, for instance, to feed text through it and to analyze the review of a restaurant from a user, which is something that we will get to see later on. Then there was recently a quite popular meme on the internet, which had a point. Actually, the point that we're making is that it is as amusing and as disturbing to understand that muffins can be very, very similar to chihuahuas. And now what we would like to do is actually test if Vision API can realize the difference. So basically, what we do, and this is something very, very interesting because it's something you can do yourselves as well, is navigating to the Google Cloud website to the Vision AI. And here, for many APIs, we actually have the chance to try it. Over here, we are able to drag an image to this box. And over here, I have the data set already. For instance, I have this one, which is quite a tricky to understand, I would say, if I was a machine. And I'll drag it over here. And I will actually have the API do a prediction. And it's very nice to use because I can understand if the machine learning API that is already built is capable of solving this problem, and I don't have to do anything else to customize the system. Some values that are very interesting to see are objects, prominent objects within the picture. And we usually get a percentage, which is the confidence rate. And we usually want to play with this by applying a threshold within the application we're developing to understand how aggressive we should be when recognizing things. And there are many examples in which it's better to claim to have detected something only when we are almost 100% confident. Then we also have labels, which give more like the values of things that this image could relate to, like dish, food, cuisine, baked goods. Another one that is very interesting is web entities, in which the API will tell me, will automatically search the web and will tell me if there are some references in the web which relate to this image, either because they match it completely or only partially. And in the end, another one that is actually quite interesting from the security standpoint and how to serve content is the safe search one, which will tell me if there is some content which is not appropriate in the image. So I might even decide to not display it within the app. Okay, so going back to the presentation, now I just wanted to dig a little bit deeper into using the APIs for actually putting them, using them within an application rather than trying them on the website. And here there are three aspects we typically think of. The first one is how we find and enable those API. On the Google Cloud Platform GUI, we will have the way to browse through a library and dashboard to see what is active, what is not active, and what is available. And for the interaction, we typically use the RESTful architectural style and JSON for the body of request as a format. In the end, a very important part is security. And over here, we have three typical ways of securing that interaction with the API. The first one, which is the easiest to manage, is through API keys. So I just create an API key related to a specific service. So whenever I use it, it will go back to my project on Google Cloud and it will give me access to it. But it is not very granular in terms of access because I cannot distinguish between users, for instance, using that API. So for these reasons, there are also other ways. One is through Oauth, and here we would generate tokens, but they would be tied to identities, so we would be able to define more granular rules. And then in the end, we have service account, which is something that we use a lot on GCP. Those are basically like user accounts, but for machines. So I will create those and I will give them privileges, and they're used when we work heavily with automation. For instance, I have a virtual machine and I want that virtual machine to automatically go and kick off a query in, for instance, a data warehouse product that we have in Google Cloud. I will not, as a user, have to approve all those transactions. I will just do it beforehand. Then I wanted also to give an example, as I said before, especially about when we review, when we try to understand what happens in a review. And here we usually use the natural language processing API. And this is quite interesting in the industry because we have many users who give their opinion about the service. And wouldn't it be great if the company itself was able to get triggered automatically when a bad review appears and take action maybe reaching out to that user. That is a very common, interesting use case. So we can go back again to demo. And here I have the Google Cloud Platform GUI. So over here I can take control over my old services. As I said before, we have the chance to go under the API and services and the dashboard, and I will be able to see which kind of APIs I have actually enabled. But from here, what we can also do is securing the access to that API. Here I have several that I've used personal. This is a sandboxing environment that I currently use for work. And we also have the credentials over here. Over here, a few days ago, I have created an API just specifically for accessing the natural language API. And I've also created, if I go back to the compute engine, a virtual machine just for using this environment. Basically, what I will do is I will just make a call using those tools that I just described now. So this is my testing environment. I've already opened an SSH connection with the machine. So over here, I've already stored the key I generated as an environment variable. And what I want to do is basically go here, and I have the call already saved, so it doesn't take that much time. And so let me show you first the input. So I have it over here. It's in this is the body of the request, and I just called it request.json. Over here we have a review of the service. I will read it out for you in case it's too little. So basically it says, I liked the sushi, but the service was terrible. So here we have two elements, the sushi and the service. And there is something positive associated to the sushi, but something negative associated to the service. That's why it's a good sentence to try, because we want to see how smart this API is, actually. So what I'll do is I'll exit from Nano, the text editor, and this is the actually call that I've just kicked. It's a lot of text. I will just guide you through it. So within the entities, we will see as the first one sushi, which is recognized as a consumer good. And the parameters that are the most interesting are the magnitude and the score under the sentiment section. The magnitude will tell me how much strength is associated to the opinion I'm expressing. And you will see that here is quite positive because it goes between -1 and +1. And the score is 0.7 because it's positive. They like the sushi. And then if we go to the service, we will see something different. We will see the magnitude at 0.9 because I used a very strong word. I said it's terrible. It's like, it's not, I didn't say I didn't like it, I said it's terrible. So the magnitude is much stronger, but also the score itself is much stronger. So now what we're gonna do is we're gonna try and modify this sentence, sorry. So basically, what we can do is, for instance, I hated the sushi, but the service, here I would like to say maybe it was just fine, so that we can sort of like, what we expect to see is a swap between those values we just seen. So there we go. We say that it was just fine. Then I will write it out. Okay. Bear with me. I'm connected through my hotspot, so it might be not the fastest. Okay. And again, we have the output. Over here we have the service, which let me check. So here I see the server. Yeah, okay, it was swapped. Okay, so I see the sushi, and here I see the magnitude as quite high. And then we see the score, but the score this time around is negative for the sentiment. Then going back to the service, I see 0.7 and 0.7. so it's positive. So there was a swap between those scores. And that was quite interesting as an example to see how we can work with that and how it can be used within an application. Then moving on, still on this topic, we have the hybrid part, which is more related to AutoML as a service. Here, the idea is to have your own data set of things you would like the API to pick up for you and be able to train them without having to know all the details about it. And an example that I like from here and that I've prepared for you already is an example about classifying images of clouds. It's nicer because we managed to realize, to recognize a little bit better through presentation. Over here, I have an environment in which I have 3 types of clouds. And I've basically already fed them to my training model, and I've already trained it as well. So I will just go down to the part related to artificial intelligence and vision, where I'm playing around with that, and go to the dashboard. Over here, I will be able both to see the vision APIs, but also the AutoML vision. By getting into this, I will see the images within my dataset. And these were images of 3 different types of clouds. So the types of clouds were the cirrus, cumulonimbus, and cumulus, which are basically types of cloud which typically indicate that a certain different kind of weather is approaching. But this can be like, this concept can be generalized and applied to many other different use cases and APIs. So in this case, I have imported my images through a storage bucket on Google Cloud, and I also gave them the solution to the problem we just discussed before. So over here, I have the reference to every single image, and I have the reference to which cloud is supposed to be. And then what I did was, well, here we are able to review all the images with the corresponding label after the import phase. Then what I did was I went through training for this model. Over here, what happens is the solution will split the data set I have, and it will use a part of it for training and a part of it for validating the, how good the training was. I'm trying to keep it high-level terms because it's still easy to use even if you're not aware of these terms. And over here, we have some evaluation points for the training. And in particular, we usually look at 2, which are the precision and the recall. So the precision is how good you are at avoiding to detect false positives. And the recall is actually the opposite. If we have a high recall, we want to produce few false negatives. A false positive is I'm trying to recognize, let's say, a cirrus cloud, and a cirrus cloud label comes up when I put the image through the filter, but it was not that type of cloud. And the false negative is the opposite. And over here, we usually want to have a threshold in the same way as we discussed before with the APIs. Because, for instance, let's take an example about security. Let's take an example of a machine learning solution which is capable of blurring sensitive information out of images. Which one of the, would you like it to be able to act on, would you like it to be able to have a lot of false negatives or a lot of false positives? Me personally, I would like it to have a lot of false positives because I would like it to claim that there was sensitive data even if there wasn't. So it's better to blur something that was not actually really sensitive as opposed to not blur something that was sensitive, because then it means you're doing a bad job as a developer. So that was an example. And over here, what we are going to do is also being able to test and use the model we've just trained. We do this by actually serving the model, deploying it onto specific nodes. And here we have the chance to upload some images. And I saved myself some images. For instance, this is a test for Cirrus Cloud. And I just upload it. And what I will do is I will get the prediction, and yeah, it's a Cirrus Cloud. So This is just a quick way to test with a few samples if what you're expecting actually happens. But then you also have the chance to go in and use it in different ways. We can go back to the REST API communication style like we used in the previous example, or we can also use other types of way of serving the model by using Cloud SDK and importing some specific libraries. So this was mainly the example related to the Vision AutoML, but we have the same thing for many other APIs as well, and we have more and more coming. And for instance, one example is I personally worked with a studio company back in Norway, and what they wanted to do is they usually build a toolkit for editing videos from games, from matches, and they wanted to recognize specific players when they were in specific highlights of the game. So what they did was basically configuring their own model on AutoML. This time around it was for Video Intelligence API, which is the API capable of processing videos, and they were able to match with the faces the players that were playing in the game. And it's just something that the API itself pre-trained from Google didn't have, because they didn't have that specific players. Moving on to the more complex part, which I will touch on very briefly, we just have the data scientist engineer part, which is for AI platform. This is a product, actually it's more of a suite of products for collaborate all together on a machine learning project. So you will be able to define models, you'll be able to train them, serve them, and also do data exploration. So there will be some services which will, like for instance, the notebooks, which will let you to have a more interactive look on data and try quick and dirty things to understand how you can work through it. Then there's the part more related to the mobile developer, and this one is quite interesting one to me. Which is the Firebase and Mel Kit. This is an SDK specifically for accessing our ML services. And it's very interesting because it lets you access both the APIs we just talked in the beginning, so with the pre-trained model, but also creating your own custom model and hosting them. And the power of this is that it will give you the chance both to rely on the cloud for doing inference, but at the same time, it would also give you the chance to do inference on handheld devices. So you will be able to export the model and bind it to the application which is running within the phone. And it will work also with more low-end phones, which have typically less resources. So it's done in a way that the binary is very light, and it's very useful for time-sensitive applications, so that you don't have to reach back to the cloud. And of course, it works offline, of course, if you don't have connectivity. Over here, as before, something similar. We have different types of APIs. Some of them I've already mentioned. A couple ones I haven't mentioned yet, perhaps, are the face detection. I can recognize where the face of people is in picture and which kind of expression they're making. And I could, for instance, drive commands within an application through that, just throwing ideas out, And we also have, for instance, landmark detection. If a user sends a picture of a place where they are, we will be able to recognize a famous landmark all over the world and localize that user. One example of this is the well-known translation API. This one can be ported into applications and run offline, and this is pretty much something that you're familiar with, because at least myself personally, I use it daily. And here's the more interesting part related to customization. This one is more trying to understand how we can port what we did with the clouds example, but onto mobile devices. Over here, I will actually go through the same process that I showed you folks just before within the GUI. And what we typically do is when we are at the time of training, we actually tell the GUI that we want to export this model as TensorFlow Lite. TensorFlow Lite is a stripped-down version of TensorFlow for running on mobile devices. And in this case, I will be able to export the model in a specific format. There are actually several different options available. And then I will be able to import it within Firebase and bind it to the application. And by doing so, I will be able to use a custom model on my own phone. One example for this is using AutoML Vision. And over here, when we export the learning and prediction part, the prediction part onto the mobiles, we usually talk about edge because we're doing inference at the edge, which is we're not going back to the cloud for that. And the example here is, for instance, let's say I have an app in which I want to recognize pineapples, but the pre-trained model only recognizes fruit in general. So if I see those 3 pictures, I will get from the pre-trained API that I will have 3 pieces of fruit in the picture. But if I train a model to recognize pineapple in pictures, then I will be able to get only the pineapple. And another example is the object detection and tracking, which is very popular, for instance, for alternative and innovative in-store experiences. Over here, I will be able to get the most prominent objects which appear in the camera when I point at them. And the second interesting part is that I will also get a general high-level categorization of those objects. So for instance, in this case, if my app is about, for instance, buying sofas, and I'm in the store, and I want to point only at sofas, I will be able to take all the other elements out of it automatically within the app and feed through a pipeline for processing data only images related to sofas. This can be a great front end, as I was saying, for a pipeline for processing data, because then I will feed those images. And for instance, I will do something that looks more like this, which is an in-store experience in which I can use vision to actually do search of products I might like to buy. The idea here is to recognize those objects and be able to feed them through, for instance, a visual search API. And over here, this is an API which lets users define a set of images for recognizing products, like, for instance, a plant or a type of shoes, and then to match them against what the camera has seen. So this is a quite interesting one. And with that, we came quite close to the end of the talk. And I have some resources that I will be able also to send out. And I would also like to ask you something, just a very, very small favor, but there's a small reward tied to it, which is if you could actually go and do the survey. It's not about the whole day, but it's more related to the machine learning itself. How do you find it? We are very curious to know if, myself in particular, if the content I put together for you folks was interesting, or if there's something else you would like to see. We want always to make things better. And I will also randomly get 3 lucky winners who will get a little bit of a swag from Google Cloud as well. And when you guys finish, or also in the meantime, if you have any questions, feel free to ask. Yeah, sure.
In a few slides, you showed an example when there was a phone that scanned some products in a shop.
Yeah.
And you were able to see the details of the product.
Yeah.
That experience was supposed to be used on an app, on the web. What's the customer journey inside the application?
Yeah. So thank you for the question. It's a very great one because I like to do so that it has a practical sense. So the idea here is that the customer journey is through an app. It goes back to a concept that exists a lot in retail, which is about being able to both shop in person, but at the same time shop online. So the idea is that the user will be able through the app on their phone to point at objects with the camera and then recognize.
This means that if a person comes to my shop, he needs to download my app, but it's very unlikely that he will do so.
Yeah.
It's any possibility to do this via web?
Yeah, so it can be done via web as well, but this issue that you're mentioning is very interesting and it's very important, and people tackle it in different ways. For instance, they will tell you, if you download the app, I will give you a discount voucher or things like that. So that's how you sort of like raise the engagement. But yeah, we could put together something similar for the web as well, because you're navigating and
of course it will be on the same performance. But
yeah, definitely.
well,
Thank you. Are there any other questions? Yes?
Thanks for the call.
No worries.
Is there any API for time series analysis?
What do you mean specifically by time series analysis? Are you looking at some type of...
ML APIs.
Mm-hmm. Yeah.
Is something specific for...
Yeah, so there are, usually the APIs are arranged more per use case. If we're looking at time series itself, like analyzing data in time, one that could be interesting is AutoML tables. And here you actually have if you have your time series data arranged in a table and you want to recognize some pattern, you can do it through that. Yeah, exactly. Are there any other questions? Questions? Yes, I see one over there. Sorry? Yes, you can also answer in Italian. I will be able to understand. Thank you. Grazie. Any other questions? Okay, looks like there is none. Just wait a second. Don't go just yet. We're gonna get the winner for our amazing swag. So I will extract random numbers between 4 and, wow, that's a lot of you guys. So just a second, don't go just yet. So I will just get some people. Okay, just do it randomly. So we have 15, 5, and 17. So we have 5. So we have this, Daniele Favaro 1. Then we have 15. We have Azzalin Tommaso. And 17, Niccolò Fanton. Please, guys, come here to collect your prize. And that's it. Thank you so much for your time today.